In this video, we explain simple interest and compound interest and how they differ from each other. One simple way to do this is to use a table. So we have here 4 columns: the year, amount in the account at the start of the year, interest earned at the end of the year, as well as the total amount in the account at the end of the year. So using an example where $10,000 is deposited into an account, that is called the principal. At the end of the year, supposing it earns 5% interest, the interest earned is $500, 5% of the principal amount. Totaling up at the end of the year, principal plus the interest earned, we have $10,500 at the end of the year. This carries over to the start of the following year, and at the end of the following year, another 5% of the principal is earned, and at the end of the year, the total is $11,000. Again, this carries over to the third year, earning an interest of $500 again at the end of the third year, with a total of $11,500. This is what we start off with at the start of the fourth year. Once again, because this is simple interest, we take 5% of the principal amount, and at the end of 4 years, that's what we have in the bank account, including interest. So our principal is $10,000, and every year, using that principal and 5% of that principal, we calculate the interest earned each year. And if you look at the interest earned over the 4 years, you're familiar with the formula. I equals to PRT over 100 is the formula to calculate the total interest earned. Moving on, let's look at how it works when it is compound interest. Using the same principal amount deposited into the bank, $10,000. In the first year, interest is 5% of 10,000, which is 500. It adds up to 10,500 at the end of the year, which carries over to the second year. The difference now is because this is compound interest, the interest earned in the second year is based on what we have at the start of the second year, which is $10,000, $10,500. All right. So now you have interest earned on the principal as well as the interest. $11,025 carries over to the third year. And once again, we take 5% of this new amount. At the end of the year, that's how much we have, which carries over to the fourth year. And once again, 5% of this new amount is calculated on the interest, giving us a final figure of $12,155.06, rounded off to the nearest cent. So, looking at how we calculated the interest, in the first year, we used what we started off with. In the second year, we use what we start off with at the second year, which is the principal plus the interest earned in the first year. In the third year, we use not just the principal, but also the interest earned in the first 2 years to calculate the new interest earned in the third year, and the same thing happens in the fourth year. We have a formula that helps us calculate the total amount in the account at the end of 4 years. And this is the formula. Total amount A is given by the principal amount P times the nth power of 1 plus R over 100. N is the number of years. R is the interest rate that is used in the calculation. So this formula, which is given in the formula list, is used to calculate not the interest, but the total amount when the principal is compounded. So there are two possible scenarios. One is if a person deposits a certain amount of money in an account to earn compound interest. But it is also possible that the person is actually borrowing money from the bank and is charged compound interest. In either scenario, we use the same compound interest formula. In the following examples, we are taking questions from the worksheet that was given. I will be selecting only certain questions from each exercise. So in exercise 1B, what you have is the deposit amount, and we are told in the question that the interest is compounded. So we know to use the compound interest formula, and the rate is 3%. Question is asking for the total amount in the account at the end of 10 years. So we can immediately use the formula, and we know this formula will give us the answer we are looking for. So by substituting P equals to 6,000, R equals to 3, and N equals to 10, we will be able to get the amount. So at the end of 10 years, this is what we have to the nearest cent. Next example, similar scenario, deposit amount is $8,000. It is again compounded interest, this time round 2.5% per annum. Per annum is simply per year. This time round, the question is not asking for total amount in the account, but is asking for the total interest earned at the end of 5 years. We will still start with the same compound interest formula to calculate the total amount at the end of 5 years. Now, if this is the principal amount, I use a long bar to represent it. And after 5 years, this is the total interest earned, I. Then our formula gave us the total amount in the account at the end of 5 years. So if the question is asking for the total interest earned, I will simply take A and subtract from it the principal amount P, and that is the pure interest earned. In this next example, we are not calculating the total amount in the account. We are not calculating the interest earned, but instead we are calculating the unknown interest rate R. What the question tells us is after 10 years, the account increases by 50%. So if we started off with 100%, it will be now at the end of 10 years, 150% or 1.5 of P. So we apply that to the formula and we get this. We divide both sides by P, we get this. How do we proceed with this formula and get rid of the power of 10? So you recall we have similar examples in indices. If you start off with a cube equals to 1.5, we can cancel off the cube by taking cube root on both sides. And we show cube root by a power that is 1 over 3. Same thing for a to the power of 5. We get rid of the power 5 by taking the fifth root on both sides of the equation, or the last example by taking the ninth root on both sides. So back to our exercise question, how do we get rid of the power of 10? We take to the 10th root on both sides. So on the left-hand side, the power becomes 1 over 10. On the right side, the power 10 disappears. Rearranging and making R the subject, we get the answer R equals to 4.14. Now, when we talk about compound interest, there is a possibility that the compounding is done over various time intervals. It doesn't have to be compounded yearly, compounded annually. Although that is the usual scenario, it can be compounded half yearly, for example, or compounded monthly. All right, we will see how the same formula for compound interest will change when the time interval is different. So let's look at 3 different scenarios. The first one is the compounding is annual, is yearly. So over 3 years, interest is 6%. We can ask two questions. How often does the bank need to so-called take out the calculator and calculate the interest? Because it's compounded yearly, interest is calculated at the end of each year. So it happens 3 times. N is equal to 3. How much is the interest used in the calculation? Because we are compounding yearly, and the question says the interest compounded is yearly and 6%, R is simply 6. And that's what the bank will use each time it uses the calculator. So our formula, when we apply it, will simply be this. And if we look at another scenario where the compounding is half yearly, same thing using the timeline, we need to cut each year into 2. How many times must the bank so-called take out the calculator to calculate interest earned? Not 3 times, but 6 times. 3 times 2. And each time, what is the calculation going to involve? What is the interest rate used? If the interest rate used is 6% for one whole year, what is the interest earned in half a year? So it is 6 divided by 2. All right. So the bank in its calculation will use R equals to 3. So you can see what happens to the formula. A equals to P, and the power is not 3 but 3 times 2, because every year is now split into 2 halves. And the rate is not 6, but now 6 divided by 2, because every year the interest is now split into 2 halves. Final scenario to look at, what if it is compounded monthly over 3 years? Okay, so it looks like this. So you can imagine calculator is used 12 times, all right, each year. And so over 3 years, it's 3 times 12. And that's the value we use for N. And you will also expect that the interest per month is not 6%, but it has to be split equally across all the 12 months. So it's 6% divided by 12. And that's the value of R used in the calculation. Same formula, but different values for N and for R. Okay, let's try an example, exercise 4B. So here what we are told is it is compound interest and its interest compounded half yearly. So when we use the formula, over 8 years, it is not N equals to 8, but N equals to 8 times 2. And the interest is not 2.4, but 2.4 divided by 2. And this is what we get, the total amount in the account at the end of 8 years. Another example where interest is compounded monthly. So we use the formula, but for N, it is 8 times 12, and for R, it is 2.4 divided by 12. And that is the total amount at the end of 8 years. Okay, next scenario, what happens if we compound the interest daily? And the question says to take 1 year as 365.25. Are we still able to do this? Not a problem. So we do the same magic for both the N and the R. For N, we multiply by 365.25. For R, we divide by the same value, 365.25. This time around, because we are trying to calculate R, notice we have to take the certain power, right? So this time around, when you take to that power, what shows up is a fraction 1 over 3652.5. And the value of R you get is 4.05.